Okay, so what is the maximum amount you'd be willing to pay to play this game?
Well, I'm just gonna assume we pick randomly for this game.
Okay, that's fine.
So you at the start, so you have this is half times, it's gonna be like A over B. We don't know how many of each.
Okay, yeah.
Then 1/2 times 1 minus, no, B minus A over B.
Okay. Nice. Okay, so we could say this is black.
Right.
And this is white. Just to be clear.
So you get A over 2B probability and B minus A over 2B probability
Alright.
of picking these.
Yeah.
Yeah. Well, if we try it, if we try it with an example, say if you have 3.
Well, sorry, you said probability for these. This is your probability picking A over B
yeah.
over B. What does A over 2B represent?
So how much is that the probability to win?
It's, yeah, if you multiply this by whatever, by the $10.
Yeah, so So this is a probability that you win for each case.
Well, we gotta be careful because the probabilities would have to add up to 1. Or
Well, this is the probability of. So the probability of winning is not going to add up to 1. There might still be a probability of losing. In fact, there is. There's still going to be a probability of losing.
oh, I see what you're saying. Okay. All right.
So, if this is the probability that you win for each case.
So there's A over B black balls,
Yep.
and there was a half a chance that you.
That you picked it.
Okay.
So if you add these probabilities up, you get B over 2B. And if you divide by B, you get a half.
Okay. So what does that tell you?
Well, that says that no matter how many black balls or white balls there are, if you pick randomly, or pick any way at all, I guess, if you could change this fraction around. No, actually, kind of. But if you pick randomly, the probability that you win will always be a half.
Interesting. What if you alter the probabilities? Let's say you only decided to pick black a third of the time and white.
A third of the time.
Do you think, before you even do the calculation, do you think that's going to improve your chances of winning? Make them worse, or leave them the same?
Oh, since we don't know these, I think it might leave them the same.
Okay. Let's do the calculation.
So for the top, we get A over 3B. Bottom, we get 2B minus 2A over 3B. So we'd get 2B minus A over 3B.
Okay.
And yeah, this is going to depend on what A and B are for each case.
That's right, that'll vary with A and B.
So we don't know.
So you don't know. So do you think it's better to pick randomly? Just half a half? Or better to...
I think it might be better to pick... I think it is better to pick randomly because at least with this you know you only have a half chance of winning, and that's the same as the other game. So
Okay.
the odds are staying the same. With the with these probabilities, they're, if you come in, like if you choose a third probability of picking the one that has a lot more balls, then you're gonna lose a lot more. So it's a lot more varied probability. So if with this half chance of winning, I think I would keep the same amount of money. It would be $4.99.
Okay, wow. Oh, that's great reasoning. This is actually a pretty famous problem. I've seen a couple people write about this problem before. So, in both cases, there's not necessarily an exact answer, which is kind of fun. This is more of an opinion. Like what would you do? But yeah, it's great. I love your explanation. Good job.